Alright, I had shelved this project about a year ago, and I just pulled it back out and started working on it again. Um, Before, I already had the clock module and the memory address register and the RAM and the RAM writing module and the instruction register. And over on this side we have the program counter and the A register, the ALU, the B register, and now I have added a new module. Down here we have the display module, which is a little faint. If I put a shadow over it, you can see it better. Basically, I can set a control line, I think it's this one, to read what's on the bus and store it in the, display it on the display register here. Actually, it's this line is the control line that puts it, that tells it to read what's on the bus. This line actually switches it between displaying unsigned byte, which 0 through 255, and this LED 7 segment will always be blank. Or if I put this to high, then this will decode the number as a 2's complement number, and it'll show negative, with this 7 segment showing a negative sign, negative 127 through positive 128. I may have that off by 1. It may be negative 128 to positive 127. I don't remember. So I've got that module made, and I've also taken a lot of the flexible jumper wires that were connecting everything to the bus and made them more permanent, the stiff flat wires, so that it cleans things up a lot. I've also added an additional lanes of bus, and I also don't think the last time I recorded a video I had extended the bus. The bus now only shows is not only 8 bits wide for the data. I've added a lane for the power, so I got positive, I got the 5 volt and ground, and I've also got a lane over here that the clock ties into. The clock module up here actually feeds into this leftmost lane, so that everything that needs a clock can just grab it right from this lane. And the memory writing register had a need to invert the clock, and so I just ran that out to a second lane in case I ever need an inverted clock for anything. Right now everything is just grabbing the main clock. Also, at one point I'd actually had a horizontal breadboard up here with wires connecting from the 8 lanes of the memory bus up to it, and eight LED, one of these LEDs like this showing the contents of the bus. That was a little awkward having a breadboard running horizontal across here, and I just ended up there's going to be some blank space on this side. These boards that are set up down here and over here are going to be for the control lines. That's these last few flexible wires I've got for things like the counter out, counter in, or jump, counter enable, A register out, A register in, A register reset. All these control lines are going to end up coming down here, even all the ones from over here that are these yellow and orange wires. They're all going to come down here, so I have them all in one central place with LEDs so I can see the status of all the control lines. And then these two boards over here are going to be the control logic that set the various different states depending on the instruction that's being executed. So there's going to be some blank space, I already know, on this side of this board, so I ended up putting the bus LED down here and just connected it straight to the bus, way down here on the bottom where it's not going to interfere with anything. So that's where we are right now. Let me see if I can actually do a little bit of a demonstration here. Let's enable the... There we go. I enabled the counter register. I enabled the counter register to count 1, so it counted up to 1, and then I disabled it. So we got a 1 on there, and I'm going to put counter out low. So that's actually going out to the bus, and we can see that down here. The LED is showing there's a 1 on the bus. Okay, and then the A register, I'm going to take A register in and take it low. So that should read what's on the bus into the A register. And I'm going to take that back high, and then I'm going to stop outputting the counter register. And we can see that the B register still has 0 in it. And the ALU is the add control line is low, so that means we're in add mode. And 1 plus 0 down here is 1. And that's what's showing on the ALU. So we're going to take the ALU and we're going to put it out to low. So now the ALU, which shows a 1, is being output to the bus. We see that down here on the register. And then I'm going to take B register in, and I'm going to take it low. And what's going to happen is that currently the bus has a 1 on it. So when I take B register in low, and I'm going to leave it low, the B register will have, on the next clock cycle, the B register will get a 1 in it. At which point, we'll have a 1 in A and a 1 in B, and the ALU will go to 2. And on the next clock cycle, that 2 will go out to the bus. And this will update to show 2. And since B is still, register is still in mode, this will change to 2. At which point we'll be adding 1 and 3. Essentially, what's going to happen is the ALU is going to count. And the bus is going to count 1 on up. And what I'm going to do is I'm going to take my display module here, and I'm going to take it to read. I'm going to change it to high to read from the bus. You can see it immediately goes to 1, and I'm going to leave that way. So once I once I take the B register in low, and it's going to start counting, and our counter will start counting here. Now, I will tell you right now, I have a bug. It seems like every 16 counts, the display register goes back to 0, all 3 zeros. And I don't know if that's because I've got some wiring wrong, or if I've got the EEPROM here that controls the data bits 0 through 8, the address lines coming into the EEPROM, which are the data byte being displayed. I don't know if I've got some of those wrong, or if I've got the actual data on the EEPROM wrong. I'm going to have to investigate that. But you'll see this go to 0. It'll count up to 15, and then it'll go to 0, and then it'll go to 17, and continue on. So let's do that. Let's go ahead and take the B register in low, and you can see right away we start counting here. I'm going to put a shadow over this so you can see it better. 12, 13, 14, and 0. And then 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 0. 32. There is some kind of a bug there. I got to track that down. But other than that, it is working. The program counter, we've got that paused. The A register is on 1. The B register is constantly increasing because the ALU is taking A and B and adding them together, and then the ALU is showing a result and putting that out on the bus, which is coming right back into the B register, so causing the B register to increment by 1 each time. And the B register is outputting to the bus, which we can see over here, and our counter is reading in from the bus, so our display is just incrementing away. Yeah, definitely something not right there. Let's see if we can watch for the next. See there, it went back to 96 and continued on. There's some bits off somewhere. I got to figure out what the problem is with that. Other than that, you can see I've made some considerable progress on this. I'll probably start working on some of the control logic this weekend. Actually, I'll probably troubleshoot the display module first and find out what's going on wrong there. Might have to pull this EEPROM and dump its contents and see what's on it. See if there's something wrong. Anyways, that's it. I will record another video before too long once I get some of the control logic done. Until next time.